Alright, so now we move on to competency 4 of pretest number 2. And our first question is, find the next term of the sequence -1, 1/2, -1/4. And then our options are 4, 1/6, -1/6, or 1/8. Well, let's switch over and look at it. So, we have, let's write out our sequence here, -1, 1/2, -1/4. And then our options are 4, 1/6, -1/6, or 1/8. So I think we can look at this right away and say 4 is obviously not an answer, not even an option for the answer here. But now we're left with 1/6, -1/6, or 1/8. What we're going to do is come back to the problem, and we're going to look at a pattern that's emerging, or has emerged. We have negative, positive, negative, so it's safe to say that following the same pattern, we are going to end up with another positive number. So let's get rid of -1/6. Now we're thinking, well, we have 1 here, then 2, then 4, so maybe 6 is next. And if we're thinking that way, well, we need to really realize something here. We have 1 over 1, 1 over 2, 1 over 4. Now what's the relationship of just our denominator? Well, it's multiplying by 2 after each. So 1 times 2, 2 times 2, 4 times 2 will give us 1/8. So our answer will be 1/8. 1/6 looks good if you look at only the second and third term, where we're adding 2, and realistically, even with fractions, that pattern wouldn't carry for long, because we have to add these together. We would have to look at our denominators. Well, really we would have 2 over 4 plus 1 over 4. So then our next term would have been 3 over 4. So that's really how we figure out our final answer is 1/8. Let's move on. So for number 29, we have find the formula for the sequence. So we're kind of at the same thing, except for this time it looks like we have whole numbers or integers. Whole number integers. And we have -5, -1, 3, 7. Well, on this one, they're giving us potential answers here and what the formula for solving this is. So first we need to switch over and talk about this. So if we have a sub n, we have where n is the, let's just pick 1, we have n minus 5. So if we have a sub 1, then we have 1 minus 5. A sub 2, we have 2 minus 5. So in this case we have a general form, a sub n and n. And for both of these, n is equal to x, where x is the position. So the first, so 1, 2, 3, 4, 5. And we call that the term's position. So if it's the first term, then x is equal to 1, where both n's are equal to 1. If it's the fifth, then x is equal to 5, n is equal to 5. Excuse me. Okay. So now we're going to look back at our potential problems here. We have a sub n is equal to n minus 5. A sub n is equal to 4n minus 9. Negative 4n plus 9 and negative 5n. So let's just go through here and say, well, when n is equal to 1 for each of these, well, then you're going to have negative 4. 4 minus 9 is negative 5. Then we have negative 4 plus 9 is positive 5. And negative 5, because negative 5 times 1 is negative 5. So when we have n equals 2, we are going to have negative 3. 8 minus 9 would be negative 1. Negative 4 times 2 is negative 8, plus 1 is 1. And negative 10. So now we have two terms. We really need 3 to establish, but in everyday life. But let's do it on this test since we're going for time. My n equals 1. When n equals 1, we need negative 5 to come back. So that's out of the question. That's out of the question. Now when n equals 2, because this is the second term in the second position, we need negative 1. That's out of the question. That's out of the question. That's out of the question. Excuse me. So I could go again, and I'm confident that if we use just to check, let's go and do 4n minus 9, where n is equal to 3, because that is the third term. Sorry, 12 minus 9 is 3. That is good. Alright, number 30. Joan has a bag of coins. She has 3 times as many quarters as dimes. How would you represent her total sum of money if D is equal to the number of dimes? So this one's really fun. We're going to actually create an equation here, or an expression. It looks like from the answers they don't actually want the equation. But how do we do that? Well, first we look at our keywords. We know that they want us to represent her total number of dimes as D. We know she has 3 times as many quarters as she does dimes. And we know that they want a sum, so we're going to use addition. Now what do we do from there? Let's switch over to the screen and see the keywords I've written down. We just talked about them. But what I'm going to look at is, well, if I know D is the number of dimes I have, and I know I have 3 times as many quarters as I do dimes, that's a start. But looking at the options for the answers, they want some values here for the money. So I know dimes are worth 10 cents each, and I know that quarters are worth 25 cents each. Now the question is, does this model what's said in the question correctly, or do we have more work to do here? Well, we know a dime is 10 cents, so that's going to, so 0.10 or 0.1, the value of a dime times the number of dimes, will give us an actual money value. So if we have if D is equal to 10, then we have $1 in dimes, so that makes sense. Then I have 3 times as many dimes, or for quarters, I have 3 times as many quarters as I do dimes, and a quarter is worth 25 cents each. So if I did have 10 dimes, like we said earlier, then I would have 30 times 0.25, which would be 15. So yeah, that would actually give us a full dollar amount, and it works. It makes sense. So now let's see if that's an option that matches. We have one very close, option B, 10D plus 25 times 3D. So we do have, ours looks a little bit different. Let's switch back over really quick and talk about why. Well, isn't. So what they have for us is 25 times 3D. Are these answers going to be any different? Well, they don't have a decimal, we do. But either way, we're still going to end up with 0.75D, no matter what. And the 10D, the only difference for theirs is they don't have a decimal for the value of a dime. They have it at 10. So they're working in cents, we're working in dollars. Divide by 100, multiply by 100, you get the same thing. So we have the same option that they do. We're just dealing in cents where they're dealing in, they're dealing in cents, sorry, and we're dealing in dollars. So there's really no difference there. So I'm going to say that yes, B is the correct option. Now, what if you're not comfortable reading these and writing them out and doing all that on your own? Or you think it's going to take you a lot longer than it just took us in this video when you're sitting there taking the test? What can you do? Well, we're going to look at each of these options and we're going to just talk about it. Well, here we have D plus 3D. Well, let's see. Joan has a bag of coins. She has 3 dimes. She has 3 times as many quarters as dimes. So 3 times as many dimes, yeah, and her dimes. That works. That is a really tempting one to jump into if we stopped reading right here. But they really want to know how would you represent her total sum of money if D equals the number of dimes. And we have the sum here. But what's the value of the dime? What's the value of the quarter? We're not discussing that in this problem. That's what really makes this look like a bad option to me. We don't have the actual value. Yeah, so if I put in 1 here, I would have 1 plus 3, and that's 4. That is not representative of an actual case with the money, because if I had 1 dime, then I would have 10 cents there and 75. I'd have 85 cents, not 4 cents. So that one's done. We're not even considering A anymore. We've already said that B is correct, so we're not going to discuss it. But C, well, look at the placement of the parentheses and then the 3 on the outside. I would have to multiply the 3n to the 10, and I'd have 30D plus 25D. Well, I don't have 3 times as many quarters now as I would dimes, so that one's out of the question. And 10D plus 25D, plus 25 times 3D, the whole value. Now I have 30D squared plus 75D. That doesn't work out either. So B realistically is the only option we have here. Well, let's move on to number 31. We're looking at elections for class president at Meadow Middle School. We have Chris, Pat, and Joe as candidates. We have their votes broken down by gender. We have boys and girls, and then we have the total number of votes they received. So let's jump right into the question. I'm not going to look for much more than that. So we want to know what percentage of the boys voted for Chris. Alright, my gut reaction, and maybe your gut reaction here, is to look at part and whole. We have 24 boys. That is the part of the whole that voted for Chris. And we know we have a total of 57 votes for Chris. So doing that, we're at 43%. And I don't see that as an option. And that's my first clue that this was not the right way to approach this problem. It wants to know the total number of boys. Well, I'm looking at the total number of votes for Chris if I choose 57 as my denominator. What is it I should have done? I should have taken the total number of boys who participated in the election, the total number of boys who cast ballots in the election. That's 24 for Chris, 19 for Pat, and 6 for Joe. So I'm at 49 total boys here. So that's my whole, that's my denominator. And I have 24 boys voting for Chris. So 24 over 49 becomes, oh, missed that one in my head, but well, it should be around 48% because I'm at 49. I'm 1 away from 50. Doubling that puts me at over 98, which is close to 100. Doubling 48. 24 is 48, so I'm at about 49%. Let's switch the screen and do that on the, so show you the math and the process here in my head, but it's pretty easy. Here we go. So I know I have 24 votes for Chris that were male, and that's what they want to know, how many of the boys voted for Chris. And I just said I have a total of 49. So this is the parts, or the boys voted for Chris with an H. And then our whole, our denominator, is the total number of boys so that's all we have to do there, and then we just pop in our calculator, 24 over 49, and let's see if my estimate was right. We get 0.4897, and there's some more data, but really we're looking for the percentage, so let's convert it into a percentage. 48.97%, and we're going to round that up to 49, which is the option B that we previously stated would have been correct. So that's all there is to that one. It's a pretty simple problem once you get past the reading portion of this test. And like I keep saying with this GK test, it's not nearly as much about math as it is being able to take what you read and apply it mathematically. That's really what they're testing you on here. Number 32. Solve 3x plus 7 is equal to negative 2x minus 8. So let's go ahead and write that down. 3x plus 7 is equal to negative 2x minus 8. Let's switch over and look at it. Alright, so what do we need to do here? Well, we need to get x by itself on one side of the equation. And how are we going to do that? Well, I'm going to look at it and say, well, I don't want to deal with the negative x because I have to divide or multiply by negative 1, and that's not anything but a waste of my time here on a time test. If it's your preferred way to do it, go for it. Go for what's right over what you are being told to do here. But I think it's just easier all around. Let's go ahead and add 2x to both sides. And then since I now going to have my x's over here, I'm going to go ahead and subtract my 7. And I'm going to end up with 5x is equal to negative 15. Well, x is equal to negative 3. Is that an option for us? What number are we on? Yep, it is option D. Let's switch over so we can see it. Alright, so yeah, D is negative 3. Let's move on to number 33. Solve the system of equations y equals 2x minus 4 and y equals 5x plus 8. So I want to know where these two equations are going to intersect. They don't have to be perpendicular or anything. They won't intersect if they're parallel, so the first thing we'll do is check our slopes. Well, if we think in y equals mx plus b, let's write that down just so we can do the comparison before we actually get into the problem. So your y is equal to mx plus b. In this generalized form, this is your slope, where your variable and its coefficient are. The coefficient m is your slope. Let's go back to our problem and just see what we have to work with. And we have 2x and 5x. They're both positive, but that doesn't mean they won't intercept, because you have to think the 2x and the 5x are increasing at different rates, so one will pass the other eventually. The y-intercept's going to play on where they pass, and their slope's going to play on where they pass. So we don't know right off the bat, and we can't just look at it and tell the point right now. But what we can do is set these equal to each 0, get the y over, and then get rid of one of the variables and see where the point lands, and then we'll substitute it back in. Sounds like a lot. Let's jump into it and we'll see how easy it actually is. So our two equations are, jumping ahead of myself, y is equal to 2x minus 4 and y is equal to 5x plus 8. Alright, so there's a couple ways to do this. I'm going to show you the way that I think is the easiest and probably the most easy to remember. We're going to take the y and move it to the opposite side of the equation so that everything, all of our variables and constants that we started with are right here on the right side. So I'm going to end up with 2x minus 4 minus y is equal to 0, and 5x plus 8 minus y is equal to 0. So now we have all of our variables, constants together. We need to eliminate one of the variables so that we can solve for the other. So we have 2x and 5x. That's going to be hard because to get that we need the coefficients to be the same so we can subtract them out. But we have a 1 in front of both of these y's, so if we can just change the sign and then they'll cancel each other out, we're good to go. So let's do that. And I'm going to look and say, well, if I end up with a negative 2x, I'm still going to end up in the positive, so I'm going to leave it at that. So I'm going to multiply this one by negative 1 throughout. And whatever we do to the left, we have to do to the right. But since it's 0 over there, we don't really have any more work to do because 0 times any number is 0 again. So we're going to have negative 2x plus 4 plus y. Oh, you know what? That is an 8. So plus 4 plus y is equal to 0. We can now add out our y's. 0 plus 0 is 0. We no longer have a y. It doesn't matter if we have plus or minus, whatever you choose, whatever you're more comfortable with. 12 and 3x plus 12 is equal to 0. We're not going to even look at this anymore, but we do need to solve for x, so the first step in that is to subtract 12 from both sides. We're left with 3x is equal to negative 12, and then we just simply divide by 3 and we get x is equal to negative 4. So there's our first answer, that's our first variable, and our final answer. I'm going to go ahead and put the box, so we know we like to keep our answers in order and put everything in a box, because it's going to be an ordered pair. Well, I have my x value, so I'm going to go ahead and fill that in. Now all I have to do, and this is the easy part, I know the value of x, so I can go back to the original two equations and pick one and substitute the x value in. I like this one. So I'm going to have 2 times negative 4 minus 4 I'm going to end up with negative 8 minus 4, where my y is now equal to 12. So I can come back in over here and put negative 12. How do we check these? Well, we put in, let's erase this part. Let's just check our answer before we even see if it's an option. I can take either of the original two equations and substitute them in. Well, I have a y value of negative 12. I'm going to do the first one. 2 times negative 4 minus 4, negative 12 is equal to negative 12. And I know you're probably thinking, hey, that's kind of the cheap route there. That's what you tested it on. Of course it came out that way. So let's do the other one. We'll do both. So now here's our second one. We're going to do it in red. We're going to have negative 12 is equal to 5 times negative 4 plus 8. Oh, now we have negative 20 plus 8 is equal to negative 12. Is that true? Well, yeah, it is. So this is a solution to the equation. Or we have solved the system of equations. And we know at negative 4, negative 12, these intersect. All we have to do to verify that we're right and help boost our confidence is check on the test to make sure we have the points negative 4, negative 12. And we do. It is letter A. It's a great mistake to make on a math video. Letter A, negative 4, negative 12. And that is the solution we came up with. So let's move on to 34. And on 34, they want to know which of the following is not a solution to the equation 2x plus 3y is equal to 24. I'm not sure what your instant gut reaction to this one is. I'm going to go ahead and write it down over here. 2x plus 3y is equal to 24. And then we have the points 9, negative 2, 0, 8, 12, 0. It's funny that they put a positive in front of the 8 there, when on all the other positive numbers they did not. And 6, 4. So what are we going to do? Well, to me, the easiest way to do this is plug and chug and go from there. So we're going to start with option A. And we have, this of course is our x value, and this is our y value. So anywhere we see an x, we're going to put 9. And anywhere we see a y, we're going to put negative 2. And we're going to see if that is equal to 24. 18 plus negative 6 does not work. We're at 12, and that does not equal 24. Well, you had to pause there because I was thinking, well, geez, I marked this one as right in my mind when I saw it. Why am I not getting it right? Well, let's read the question again, because I just got caught up on one of the things that I've been telling you to be careful with. But I got caught up on the easiest one. This is not even a tricky question. This is so straightforward. Which of the following is not a solution to the equation? And I'm sitting here looking at my work going, well, why did I think 9, negative 2 was right when I started this video, and now I'm sitting here in silence feeling awkward? Well, I just misread the question. I forgot that it is not a solution. Really, we don't have anything else to test. I found the one that is not the solution. If your nerves are going to get to you, if you're anxious like I am, you may want to test the other 3. I'm sitting at home right now. We're talking about this video. I don't want to drag it out. I found one that is not a solution. I'm going to move on and bank that time. Alright, so now we want to know for 35 which is a solution to the inequality 3x is greater than negative y plus 7. You know, if I were you and this was the actual test I was taking, I'd be very thankful that these questions are coming up for me. These are very simple. We're in competency 4 now. So these are some very heavily weighted questions. Knowing these is going to do so much more, and getting these right, and these are pretty easy, than getting all of competency 1 right, or all of competency 2 right. Competency 3, 4, and 5, really where people start getting hurt on the test, where their numbers kind of drop, and since this is a weighted test by competency, they start doing worse because they mess up or make their mistakes in the higher competencies. I'm going to tell you 3 and 5 That's where I see most of the mistakes. 4 is really a lot of people's strong point. So this is the competency where you want to get 100%. You don't want to get an 80 in this one, because this is the make or break competency for everyone, because so many people are so much more comfortable with this than they are with the other 3 and 5. Well, without going on any further, we have 3x is greater than negative y plus 7, I believe. Yep. And we want to know which of the following is a solution. And then we'll do it point by point instead of waiting it out, since we got lucky last time and it was option A. So we're going to test first negative 4, 3. Well, you can hear the dog running across the floor. That's pretty funny. So if I know this is my x value and this is my y value, I'm going to have 3 times negative 4 is greater than negative 3 plus 7. I'm going to end up with negative 12 is greater than 4. That is not true. Therefore, it is not a solution to this inequality. And we are looking for the solution this time. So let's go to the point 2, 1. So my x and my y, and this is the last time I'm going to do it because I'm pretty sure we're all comfortable with that now. 3 times 2 is greater than negative 1 plus 7. 6 is greater than 6. Nope. We would need greater than or equal to make this true, and we do not have that, so this one is not a solution. Let's go on to our third point. We're running out of room, so hopefully this is it. We have the point 3, 9. So anywhere I see x, I'm going to plug in 3. So we're going to have 3 times 3. Jumping ahead here. 3 times 3 is greater than negative 9 plus 7. Oh, I'm going to have 9 here is greater than negative 2. That's true. This is a solution. Yeah, I'm not great. I'm writing everything out of order here. I'm sorry about that. I'll stick to the math. Don't worry. All right, so that's it for 35. We know that the point 39 is a solution. We know it's an option because I'm taking them right off the test, so we don't even really need to check that. So we're going to move on to 36. And this is the fun one. This is where we take all the skills we just used and we throw it together. This is one of the ones I'm talking about where a lot of people are good with a lot of the algebraic thinking, but then you get here and I see so many mistakes, and this is a costly question to miss because you're going to spend a lot of time on it. And missing it is going to hurt you. Well, let's do number 36, which happens to be the last problem in competency 4 on this test. So we're given which is the solution to the system of inequalities. Y is less than 2x plus 7, and y is greater than or less than negative x plus 3. And then we're given 4 points, A, B, C, or D. So we're going to solve these real quick. I'm going to show you 2 ways to do it. And here we go. So we know we have y is less than 2x plus 7, and we have y is greater than or equal to negative x plus 3. So there's 2 ways to do it. I'm going to show you the first way with a graph. We're going to first graph these 2 lines, and I know I'm going to go ahead and put the t-table here. So a lot of people do it, but we know when x is 0, our y-intercept is going to be 7. And we'll just go from there. Let's not get all into it because that's a waste of time on the test. So we're going to go ahead and come in here and we'll graph 0, 7 for our x-intercept. We know the slope is 2. So we can go up 1 over 1 to get our second point. Or up 2 over 1, sorry. And we go down 2, left 1 to get our third point. That's what we need to make a line. And now I need to get my protractor on here and figure out pretty good luck. Let's just pretend that's continuous. Alright, and I went ahead and drew a solid line because it's just strictly less than. And then I'm going to graph this one. I'm not going to go and do the t-chart or anything. We know that if x is 0, y is 3. So we'll go ahead in a new color. And we know we have a negative and an understood 1 coefficient here. So we can go up 1, left 1 for our second point, and down 1, left 1 for our third point. And then we're going to fumble with this protractor again, trying to find the point where alright. Now we have the two lines marked. This is y is greater than or equal to protractor in the way. It's not negative x plus 3, and this one is y is less than 2x plus 7. Alright, so we have to look at our signs here. We have less than, so anything less than, any x value that makes this true would have to be less than the y value. So we're going to shade in this direction. These are all of the values where y is actually less than the x value. And then we are going to look at this one and say, well, y is greater than or equal to. So we know we need to go greater than or equal to on this one. Well, greater than. And then we're going to look at the point where are the section of these two graphs, because if you look, it makes 4 pieces. We have 1 here, 2, 3, 4. We're going to look at the one where both points fall in here, and that's in the first section here, section number 1. So we can look at our options real quick and see which one of these would fall in this area. -1, -4. Does it fit in here? Let's go back 1. So -1, -4. We're going to go into pumpkin color here. We have -1, -4. That point is A, and that does not go in here. It does not fit. It is not part of our overlapping section. Now we're going to look at 1, 6. That's looking pretty good to me. We're inside of it. Section 1 like we want to be. So let's test the other points just to make sure we haven't made a mistake, or that we really can see that that is the one correct solution. Next up, -4, -5. We go to -4, -5. Oh, that doesn't qualify either. And 0, 2. 0, 2. Well, that's close, but it's not quite there. It's below. And it's less than. The y is greater than or equal to -x plus 3. But we need greater than. So B really is the only point that fits in this whole criteria of these two. So it is the only solution given. So we're going to go ahead and mark B for our choice. Alright, the other way to do this, and so we would do 2. There's this way. On the test, you're not going to want to sit here and draw out the coordinate system and all that and then fill it all in. So what you can do really quick is just say, well, I'm just going to test this one. Y is less than 2x plus 7. I'm going to plug in each point. So I'm going to have -1 plus 7 is less than -4. Well, I'm going to end up with -2. That's going to be -4 is less than 5. False. So it's not a solution. I'm going to put 1, 6 in. So I'm going to have 6 is less than or equal to 2 times 1 plus 7. And we're going to end up with 9. So 6 is less than 9. That is a solution, or true. So what we can do there is go ahead and test that in the second one. It'll come out true also, and we're good to go. That's how we can do it that way. So you could just plug and chug the points.